Hello, this video is on right-angled triangles, specifically right-angled triangles that occur in three-dimensional objects, as shown here in the syllabus. When performing trigonometric calculations on your calculator, make sure that your calculator is set to degrees. To do this, from the main menu, select Run Matrix, and then press Shift menu to enter Setup. And press the down cursor to scroll down to the Angle option, and then press F1 to choose degrees, and then press Execute. In this question, you're asked to find the length of the diagonal, DF. If we start by identifying the diagonal, and then in triangle BCD, which is right-angled at angle C, use Pythagoras' theorem to calculate the length of BD, the hypotenuse of the triangle. Square in and add in the shorter lengths of the triangle, and square root in the result, giving BD is equal to the square root of 41 centimeters. Then in triangle BDF, which is right-angled at angle B, using Pythagoras' theorem again to calculate the length of DF, the hypotenuse of that triangle. Square in and add in the shorter sides of the triangle, and square root in the result gives the value shown. So the length of the diagonal DF is 8.77 centimeters, correct to three significant figures. In this question, we're asked to find the angle between the line AG and the plane ABCD in the cuboid shown. If we begin by identifying the angle required, letting the angle GAC equal theta. In triangle ABC, which is right-angled at angle B, we can use Pythagoras' theorem to find the length of the hypotenuse, AC. Square in and add in the lengths of the shorter sides of the triangle, and square root in the result gives AC is equal to the square root of 58 centimeters. In triangle ACG, which is right-angled at angle C, we can use trigonometry to find theta. Identifying 2 centimeters as the side opposite theta, and the square root of 58 as the side adjacent to theta. Referring to the trigonometric triangles, tangent is equal to opposite over adjacent. Write in tan theta equals 2 over the square root of 58. Additionally, if we cover up the tangent in the triangle, we see that we need to divide opposite by adjacent. Performing inverse tangent on the calculator, so that's pressing Shift tan to access inverse tan, and then putting a bracket and pressing the fraction button and putting 2 in the numerator, scrolling down, pressing the square root symbol, and then 58 in the denominator, and the right cursor to come back up twice, and then closing the brackets and pressing Execute to perform the calculation. So the angle between the line AG and the plane ABCD is 14.7 degrees, correct to three significant figures. Alternatively, you can use Solver on your calculator. From the main menu, select Equation, press in F3 for Solver, and then typing in the equation. So pressing tan, and pressing the X variable button to represent theta, and shift to access the equals, again pressing the fraction button, and 2 in the numerator, scrolling down and pressing shift to access square root, and 58, pressing execute to enter the equation. Just to note that the number next to x is not the solution to the equation, as we haven't pressed solve yet. Pressing F6 to solve the equation, again given a value of 14.7, correct to 3 significant figures. In part A of this question, we're asked to find the angle between the sides VA and VC. If we start by identifying the angle required and letting angle AVC equal theta, as shown. In triangle ABC, which is right-angled at angle B, we can use Pythagoras' theorem to calculate the length of AC, the hypotenuse of the triangle. Squaring and adding the shorter sides of the triangle and square rooting the result. So from the main menu, selecting Run Matrix, pressing Shift to access the square root, and that's 4, pressing the squared button, plus 4, the squared button again, pressing Execute to perform the calculation. Gives AC equal to the square root of 32, which is equal to 4 square root 2. Finding AM, which is half of AC, so dividing by 2 gives 2 square root 2. As triangle AVC is isosceles, angles AVM and CVM will be equal. In triangle AMV, which is right-angled at angle M, we can use trigonometry to find angle AVM. Identifying 6 centimeters as the hypotenuse of the triangle and 2 root 2 as the opposite to angle AVM. Referring to the triangles, sine is opposite over hypotenuse. Writing sine of angle AVM is equal to 2 root 2 over 6, and then using inverse sine. So on the calculator, pressing the Shift sign button to access inverse sine, opening a bracket, putting a fraction button, and putting 2 and a Shift to access square root 2 in the numerator, and then the down cursor to come to the bottom, and putting 6. Pressing the right cursor to come back up, and closing the bracket, pressing Execute to perform the calculation. Given the value shown, and multiplying by 2 to find the angle AVC. So the angle between the sides VA and VC is 56.3 degrees, correct to 3 significant figures. In part B, to find the height of the pyramid, identifying the height on the diagram, we can use Pythagoras' theorem to find h. Squaring and adding the 2 shorter sides and equating it equal to 6 squared, the hypotenuse squared. Simplifying the calculation, subtracting, and then square rooting gives the value shown. Alternatively, we can solve the equation on the calculator. From the main menu, select Equation, press F3 for Solver, type in the equation, so bracket, and then 2, Shift to access the square root, and then 2, and then the right cursor, and then closing the bracket, and pressing the squared button, and then pressing the X variable button to represent h squared. Again, shift to access equals 6 squared. Pressing execute to enter the equation, and F6 to solve the equation. So the height of the pyramid is 5.29 centimeters, correct to 3 significant figures.